In our last session, we applied two separate network policies to the front-end namespace to block all inbound and outbound traffic as shown in the diagram. While using two policies helped us visualize the traffic isolation, we can achieve the exact same result, default deny behavior with a single policy. By specifying both Ingress and Egress under the policy types without any explicit rules, all incoming and outgoing traffic is blocked by default. Step 1 of Zero Trust model requires us to restrict all baseline traffic. We have already done this for frontend, and now we'll apply this same single policy default deny approach to the middleware and the backend namespaces. Let's apply it to the middleware namespace to start with. Let's apply it, and then we'll apply it to the backend namespace now. It's done. We'll also verify whether these policies are created successfully by running these get netpol commands against these appropriate namespaces, both middleware and backend. We could see it's created. And you can also run the Kubectl describe command to get more information about these network policies. So effectively, the network policies are already created. Now that the policies are applied, let's verify them by running our validate connectivity.sh shell script. So the script shows that all connections are terminated, confirming that both Ingress and Egress traffic are fully restricted across all the three namespaces. A quick recap. So we started with an open cluster where any pod could talk to any other pod. By enforcing the default deny policies, we have locked down all traffic, creating the ideal baseline for zero trust architecture. In our next section, we'll selectively open up access to so the traffic flows only where it is supposed to, from front-end to middleware and middleware to backend namespace. Under no circumstances should front-end communicate directly with the backend namespace. So see you in the next lesson.